Take a look at a modern Indian 100 rupee note. Down in the bottom corner, you'll see a small, crisp emblem, 4 lions standing back to back. That symbol is a direct replica of the Sarnath lion capital, carved out of a single block of sandstone over 2,000 years ago. The stone is so highly polished it almost looks like glass. Building something this permanent was a massive departure from how ancient Indian cities were traditionally constructed. Early urban centers, like the capital of Pataliputra, were built almost entirely out of wood and mud brick. That posed a massive engineering problem. Wood rots and mud dissolves. Decades of heavy monsoon rains meant that a ruler's physical legacy was constantly splintering, decaying, and eventually washing away. To leave a lasting mark, builders had to abandon wood and reinvent their entire relationship with building materials. It kicked off a centuries-long technological race to outlast the environment. That race accelerated under the Mauryan emperor Ashoka. He needed a medium that wouldn't rot so he could broadcast his moral policies, known as Dhamma, across his vast territory. The first major breakthrough was mastering stone extraction. Engineers quarried massive blocks of sandstone from the Chunar region, transported them, and polished them into towering, freestanding monoliths that still stand above the ruined brick foundations of early cities. At the same time, builders stopped erecting wooden halls and began carving spatial environments directly into the solid bedrock of mountainsides, like the Barabar caves. Because they were used to woodworking, they forced this rigid stone to mimic their past. If you look at the entrance to the Lomas Rishi cave, the rock is specifically carved to imitate bent wooden beams and sloping thatched roofs. This Mauryan rock-cut technique proved that human engineering could make heavy, solid stone behave exactly like familiar, livable architecture, while rendering it immune to the elements. Mastering stone as a structural medium provided a permanent canvas for a new level of detail. Having conquered the physics of carving mountains, builders now possessed the technical skill to tackle a much more intricate engineering challenge, even replicating the human form in rock. A few centuries later, the Kushana Empire expanded to the northwestern borders, bringing Indian traditions into direct contact with Greco-Roman artisans. This collision birthed the Gandhara school of art. Using local gray schist stone, sculptors carved figures with heavy, realistic wavy drapery and defined muscular features that closely mirror Roman statues. But at the exact same time, deeper in the Indian heartland, a different approach was developing: the Mathura school. Mathura artisans utilized indigenous red sandstone instead. Instead of hyper-realistic clothing and deep folds, they focused on smooth, physically robust body shapes, prioritizing serene expressions and inner spiritual energy. By supporting both regional styles simultaneously, the Kusans successfully blended foreign realism with indigenous spiritual aesthetics, creating the first permanent representations of the divine in human form. The final leap in this ancient materials arms race occurred during the Gupta period. Builders transitioned from carving horizontally into existing mountainsides to constructing vertical structures from the ground up. This led to the Nagara-style structural temple. By mastering the engineering of stacked stone and heavy structural masonry, they built freestanding temples, like the Dashavatara at Deogar, allowing architecture to finally reach skyward. Their command over materials extended beyond masonry. Under Chandragupta II, engineers achieved a mastery of metallurgy that surpassed their work in stone. Their most impressive surviving accomplishment is the Maurya iron pillar in Delhi. It is a 23-foot-tall, 6-ton column of solid iron. Despite standing completely exposed to the sun, rain, and humidity for over 1,600 years, it has never rusted. This combination of structural masonry and advanced metallurgy meant the Guptas had achieved what their predecessors could not: a physical legacy capable of resisting the natural forces of decay indefinitely. Over a few centuries, builders evolved from constructing temporary wooden halls to erecting polished sandstone monoliths, skyward-reaching masonry temples, and rustless iron pillars. The structural templates developed during the Gupta era let in the spatial blueprints for all future Indian architecture, laying the direct foundation for the massive, towering spires, or shikaras, of modern temples. Because these heavy stone structures were finally built to last, the fragile, vibrant artwork housed safely inside them survived for millennia. These monuments, and the emblems sitting in our wallets today, stand as the physical evidence of a civilization that successfully engineered its own immortality.